Okay, in this video we'll go on to one super duper example of integration by substitution involving a definite integral and a change of variable. The first thing we're going to do here is rewrite this to get integral from 1 to 5 of x times 2x minus 1 to the negative 1/2 power dx. We have our function composition. 2x minus 1 is the inside function. Its derivative, though, is just 2, and that's not going to take care of the x on the outside. So after we do everything else, we're still going to need to swap out. We're going to need to solve for x in terms of u. So we let u equals 2x minus 1. du is equal to 2 dx, and 1/2 du is equal to dx. So we swap out the 2x minus 1 for u, the dx for 1/2 du. We still need to take care of the x on the outside and the limits of integration. Well, if u is equal to 2x minus 1, then x is equal to u plus 1 over 2. And when x is equal to 5, u will be 9. And when x is equal to 1, u will also be 1. So we begin our rewrite with integral from 1 to 9 of x, which is now u plus 1 over 2, times u to the negative 1/2 times 1/2 du, and simplifying that all out, we get 1/4 integral from 1 to 9 of u to the negative 1/2 times u plus 1, which we can then distribute to get 1/4 integral from 1 to 9 of u to the 1/2 plus u to the negative 1/2 du. And we're ready to integrate that now. U to the 1/2 is going to become u to the 3/2 over 3/2, or 2/3 u to the 3/2. We still have 1/4 on the outside. U to the negative 1/2 is going to become u to the 1/2 over 1/2, or 2u to the 1/2. We're going to integrate that from 1 to 9. So 9 to the 3/2 power is square root of 9, which is 3, to the third, which is 27. And 2/3 of 27 is 18. U to the 1/2, or 9 to the 1/2, would be the square root of 9, which is 3, times 2, which is 6. So when we evaluate the antiderivative at 9, we get 18 plus 6. Evaluating at 1, we're going to get 2/3 plus 2. That gives us 1/4 of 21 1/3, which is 1/4 of 64/3, which is 16/3. Okay, and I will put out one for you to try. That would be the integral from 0 to 4 of x over the square root of 2x plus 1 dx. And you can pause the video and I will give you the solution to that, or the answer to that, when you turn it back on. Okay, so the answer to that should be 10/3. If you get it, then we're done with this series of examples. If you need me to step through that, I will do that at this point. So the first thing that I want to do here is to rewrite that as integral from 0 to 4 of x times the quantity 2x plus 1 to the negative 1/2 dx. If u is equal to 2x plus 1, du is equal to 2 dx, and 1/2 du is equal to dx. Now I can swap out the 2x plus 1 for u, the dx for 1/2 du. Now I still need to swap out the x, so I'll need to solve u equals 2x plus 1 for x, and x is u minus 1 over 2. Then I need to swap out my limits of integration. When x is 4, u will be 9. When x is 0, u will be 1. And we're ready to begin putting all the pieces together. So I have, once again, I have two halves. I have the half on the half du, and I have the half on the x. I'm going to bring them out to get 1/4 integral. Limits of integration are now 1 to 9. I have u to the negative 1/2 times u minus 1 du. I'm going to distribute. And now I finally get 1/4 integral from 1 to 9, u to the 1/2 minus u to the negative 1/2 du. U to the 1/2 becomes 2/3 u to the 3/2. That's minus u to the negative 1/2 becomes 2u to the 1/2. I'm integrating that from 1 to 9. Once again, the 9 to the 3/2 is 27. 2/3 of 27 is 18. This time it's minus 6. Then 2/3 minus 2. That gives me 1/4 of 13 1/3, which is 1/4 of 40/3, which is 10/3.